Good morning everyone. So this is our next lesson in our bonding topic, and today we're going to have a look at covalent bonding. So do you remember from the introduction video, or maybe from the first lesson that you were looking at that Mrs. Bingham had put together, was that covalent bonding happened between non-metals, and it's to do with electrons being shared. So electrons are shared, the two non-metal atoms share electron to get a full outer shell. And remember we talked about, depending where they were in the periodic table, how they would get full outer shells of electrons. And we're going to be looking a wee bit at the periodic table today about looking to see how many electrons there are in the outer shell and what type of bonds they might form. So in terms of covalent bonding, our simplest example is hydrogen gas. I've got the jelly tots to show you as well. So the line in between them represents a covalent bond, or the cocktail stick represents a covalent bond. And hydrogen gas, hydrogen has only got one electron and one proton, so it's got one electron in its outer shell. And the question here is, how can it get a full outer shell? So remember, the first shell can hold 2 electrons. So if we have 2 hydrogen atoms, each of them with 1 electron, if they overlap and if they share their electrons, then this hydrogen atom has 2 electrons in its outer shell, and this hydrogen atom has 2 electrons outer shell. So by sharing it, and we can also write it like this, and the line represents that shared pair of electrons, or the covalent bond. And the little model, then the cocktail stick, represents the bond, and the jelly tots represent the atoms. Okay, so I'm going to look at a couple of other examples here. So if we look at chlorine gas, we've got a different colour of jelly tots. So in our last video we talked about ionic bonding, and I drew out the whole structure and how it can form an ion by gaining an electron, but that's only if it reacts with a metal. So remember, covalent bonding is between 2 non-metal atoms. So if we have 2 chlorine atoms beside each other, so remember chlorine is in group 7, so it's got 7 electrons in its outer shell. And if we have 2 chlorine atoms, now the good news when we're doing covalent bonds is normally we just have to draw the outer shell, which is great. It means we don't have to draw all the electrons. So if we have 2 chlorine atoms, each with 7 electrons in the outer shell, same as what we did with a hydrogen, if they share their outer shells, then they can both get 8 electrons in their shell. So in this case, the outer shell to be full needs 8 electrons. So if you look inside this circle for this chlorine atom and count, there's 8 electrons. And if you look inside this circle for that chlorine atom, there's also 8 electrons. So we'll see then that both of them are happy, both of them have the full outer shell, and we can draw it like this. Or the formula then is Cl2. So there's 2 chlorine atoms in the molecule. Okay. So our next example then is a water molecule. So you're all familiar with the formula H2O, so there's 2 hydrogens and 1 oxygen. Okay, so if we look at how the electrons are, so again we've got our hydrogen atom with 1 electron in each outer shell, and we've got our oxygen atom. So our oxygen atom has 6 electrons in its outer shell. So for them to form, for all of these atoms to have a full outer shell, they can share their electrons in covalent bonds. And you'll see here that we have the hydrogen sharing its electron with one of the oxygen's electrons. So the hydrogen's outer shell is full, it has 2 in it. Same for that one. And then the oxygen has 8 electrons in its outer shell. And we can write it like this. You might see it written. So each of those lines, remember, represents a covalent bond, which is the shared pair of electrons between the atoms. Okay, if I'm going too fast, just pause the video and rewind it, and you can have a wee look again and check if there's something you don't understand. There's also information in the booklet that Mrs. Bingham has prepared. So the next stage in your booklet, I want you to draw, using the circles and the electrons, draw the bonding in these. So we've got our water molecule, just showing you the molecules, and in school we have the actual molecules, not just jelly babies that you'll be able to see. We've got hydrogen, we've got methane, and we've got hydrogen chloride. Okay, so they all are what's called single bonds, or single covalent bonds, where there's 1 shared pair of electrons, just like we've been practicing. So if you want to pause the video now and complete that table in your booklet. Okay, hopefully you've got that filled in, okay? And then we're going to have a look at an example with a double bond. So this is carbon dioxide. So it's got 1 carbon and 2 oxygens. So if we look at how the electrons are in their atoms, so in the periodic table, remember if we look at the periodic table, so here's our little reminder, the group number in the periodic table tells you how many electrons there are in the outer shell. So carbon is in group 4 and oxygen is in group 6. So that tells you that there's 4 electrons in the outer shell of carbon and 6 in the oxygen. And they both want to get 8 in their outer shell. So how are they going to do that? Do you want to pause the video and have a think about what you think this is going to look like? And the answer is they do that by sharing 2 pairs of electrons. So each of these overlap here. There's 2 electrons from oxygen, 2 electrons from carbon, 2 electrons from that oxygen and 2 electrons from carbon. So you'll see here that instead of having the single lines like we had before, we've got a double line which represents a double bond or 2 pairs of electrons shared between the atoms. And that's what your carbon dioxide molecule looks like. Okay, so for you now in your booklet, there's a challenge to try and stretch yourself to see, can you draw what the bonding in these molecules look like? So oxygen gas, there's my oxygen, you can see there's a double bond there. And then my nitrogen gas, so nitrogen's the gas that you find inside your packet of crisps. It's also the main gas in the atmosphere. So have a think, look at where nitrogen is in the periodic table and see if you can figure out how the bonding is. If you have any questions, just send your teacher a wee message and they'll help you. Okay.